In this video, we're going to use the product and quotient rules to simplify radicals. We're going to be doing problems like those from 15.2, numbers 1, 9, 15, 21, 33, 39, and 41, 45, and that'll be it. All right. Start off with what I mean when I say the product rule and the quotient rule. So the product rule is that if I have a product inside of a root, that it can be broken down into the product of those individual roots. And similarly, the quotient rule says if I have a quotient inside of a root, that it can be broken down into the quotient of those respective roots. Everything that I'm going to be using as an example in this video is just going to be square roots, but these rules also work with other indices as well. So let's go ahead and get rid of these. Square root of 40. So what I want to do is I want to look for a factor of 40 that's a perfect square, like 4. And the other part I don't want to contain any perfect squares. I want the largest perfect square that is a factor of this number. If I need to break it down into several factors that are perfect squares, that's fine, it'll work as well. This would be the square root of 4 times the square root of 10 is 2 times the square root of 10. Next problem is the square root of 54. 54 is 9 times 6, and 9 is a perfect square. This is 3 square roots of 6. Next problem is just 3 square root of 25. There's not really anything to break down here because 25 is a perfect square. This is just 3 times 5 is 15. The next problem is the square root of the quotient of 147 and 100. So this is root 147 divided by root 100. 147 is 3 times 49. Square root of 49 times 3. Root 100 is root 49 times root 3 over root 100 is 7 root 3 over 10. Next problem here is the square root of x to the 13th power. I'm going to break that up into x to the 12th with another x left over is the square root of x to the 12th times the square root of x is x to the 6th on the outside, and the square root of x is left on the inside. We could also use remainder division here, and that works very well. So I'll show you that the index is 2. So 2 goes into 13 6 times with a remainder of 1. So there's a power of 6 on the outside and a power of 1 left on the inside. It's one of my favorite ways to do these that have big exponents inside of roots like that. Now I have the square root of 48x to the 10th. 48 is 3 times 16. That's going to be 4. X to the 5th comes out, and the 3 is left on the inside. takes me up through 39. I've got two more problems here. Three more problems here. So the square root of 8 over m to the 6th is the square root of 8 over the square root of m to the 6th. Square root of 4 times 2 is going to be 2 root 2 over m to the 3rd. You have the square root of 4x over 10 over y to the 10th. Be the square root of 4x over the square root of y to the 10th. It's going to be 2 square root of x over y to the 5th. Square root of 162 over y to the 6th is the square root of 162 over the square root of y to the 6th. Is 162 is 2 times 81. Is 9 root 2 over y to the 3rd. That's everything for this video. And we will come back next time and talk about adding and subtracting like radicals. See you for the next video.